In this video, we're going to solve the two-sum problem. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's take a look at the examples. In the first example, nums is 2, 7, 11, 15, and target is 9. Since nums 0 plus nums 1 equals 9, we need to return 0, 1. 0, 1 are the indices of the array. The second example is basically the same as the first one, and the third example, the element 3 appears twice in the array, and the target is 6. The two 3's are considered as different elements in the array. Since nums 0 plus nums 1 equals 6, we need to return 0, 1. How to solve it? A brute force approach would require to calculate the sum of every pair in the array and check if that sum equals to the target. In pseudocode, it looks like this. For I in 0, m minus 1, where n is the size of the array. That's for every possible number in the array. And for j in 0, I minus 1, if nums I plus nums j equals target, return the pair ij. How many pairs are there in an array? It's n times m minus 1. So the time complexity of this approach is n squared. Can we optimize that? It turns out we can. The inner loop checks if there is a number that equals to target minus nums I. The brute force approach takes linear time to scan every number in the array. If we store each number and its position in the array, we can check this criteria with the dictionary lookup. Let's see how that works with an example. Say the nums array is 2, 7, 11, 15, and target is 13. So first I is 0, nums I is 2, the dictionary is empty, because 13 minus 2 is 11. Is 11 in the dictionary? No. We move to the next I. Dictionary now is 2 and its position 0. 13 minus 7 is 6. Is 6 in the dictionary? No. We move to the next I. The dictionary now is 2, 0, 7, 1. 13 minus 11 is 2. Is 2 in the dictionary? Yes. So we know to return 2, 0. Because dictionary lookup takes constant time, we have optimized the inner loop from linear time to constant time. The whole algorithm would take O(n) time to complete. Let's look at the code. Sin is the dictionary. Enumerate gives the index and the value from the array. It's just a simpler way to iterate through the array. Other is the other number we're looking for. If other is in the scene dictionary, return its position and I as a list. Else, we store the number and its position in the dictionary. Let's submit the code. And it's accepted.